Welcome to part 2 of the hard math questions. Okay, we left off by doing this question. I hope you guys could understand this question. Okay, and now let's continue with these. Before starting, of course, like, subscribe, and share, and let's go. Okay, so we have this, and you need to find x. Now, if you have read my notes, you will remember this shape. Okay, and you will also remember this property where these two angles are same because they are vertically opposite, you could say, because this can be just corresponding and then vertically opposite. Nice. Okay, so we can use this rule here as well. Okay, where if we extend this line, we can copy x all the way to here, then we can just do alternate in a vertically opposite to get x all the way over here. Boom. Nice. Next, we know this angle is 90, so is this angle 90, and we know that ED and EB will be same. Okay, will be of same length. Why? Because you guys have read my notes as well, and these two are radiuses, so these are equal. Now using side angle, okay, we know that these two are congruent triangles, meaning this angle will also be x degrees. Okay, nice. Now using this, we know every angle of the triangle, and so we can solve for x. This is 180 is equals to 90 plus 44 plus x plus x. 90 plus 44 is equals to 134. 180 minus 134 is equals to 46 is equals to x. X is equals to 23, and that is your answer. Boom, very easy. Okay, let's now move on to this God-forsaken question. I actually made a Desmos graph for this. Okay, but no need to whip it out. Okay, I'll just explain it to you. Okay, if you guys can understand it. Okay, let's start with this. Now, what is our goal? Our goal is to find this angle AG. Find this angle. Okay, now this angle is not made from AFG. People think it is made from AFG. No, this is a completely wrong assumption. Okay, and not the correct triangle that we are trying to find. Okay, this is actually, if we make a perpendicular from G downwards, let's call it x. Okay, this is the same as these four perpendiculars. So like if we see this cuboid here, this cuboid shape that we have just made, then it is this cuboid that has this angle. Okay, if we make this, then we can see that the question actually asks for xag instead. Okay, so let's combine this line here, and you can see it asks for agx. Okay, so how do you find agx? Now we know that this distance ex is same as will be 7 centimeters. Why? Because if we draw a drop down here, this is 7 centimeters, and so this is 7 centimeters also, and this is 3 centimeters. We don't care about that. We just break up the entire 10 centimeters into 7 centimeters and 3 centimeters. So this is 7 centimeters, and we know this is a cuboid, so this also will be 7 centimeters ex. So using this, we can find the this triangle is hypotenuse. Okay, and this so this side will be 15 as 15 of course. So what do we have here? We have ex y a. Now this will be y, ay is equal to 7, and this hypotenuse is what we need to find. Okay, so let's just use our good friend Pythagoras to do so. So this is square root 15 squared plus 7 squared is equals to root 274, which I will approximate to 16.553, 3 decimal places. Okay, so we found this, we found ax finally. So next step is to find ag. Okay, now we know that this height gx will be 5 centimeters. Why? Because since this is a cuboid, these will be the same. So meaning this is also 5 centimeters. Okay, gx 5 centimeters. So we can use the triangle AXG as 7 centimeters, and this value that we found, which is 16.553. Now the question asks for this angle right here, like we said. Okay, so how do you find this? We do not have any hypotenuse value. Okay, so we can use tangent instead. So tangent of theta is equal to opposite over adjacent, TOA 553. I'll just write it on my calculator. Inverse tangent of 7 over 16.553 is equals to 22.92 centimeter, 92 degrees, or 22.9 degrees, because 1 decimal answer rounding, and that is our answer. Okay, I hope this you understand this question. If not, just rewind the video, please. Okay, but a recap, we found ax. Okay, and then we found the triangle. We found the angle using this triangle. Let's skip this. I put this question in here. Okay, that's because I found this cake. You know, I am hungry right now, but this cake is insanely detailed for no reason at all. Okay, props to Cambridge. Okay, this question I found. Okay, but before that question, we need to tackle. No, it's okay. Let's just be in order. Okay, this question I found, some people were having trouble with it. Okay, who are doing 4024 O levels. Okay, and I think it's a good for IGCSE also. Okay, now you won't do past papers way back then 2013, but you know, people do come across 2013s at some point. Okay, now we want to find the area of the shaded region in terms of pi. What are we given? O is the center of circles with radii 1, 2, 3, 4 and 5 centimeters. The cover has rotational symmetry of order 6 and BOC is 40 degrees. And we need to calculate the area of the shaded region. Now, we know 1, 2, 3, 4 and 5 centimeters. 5 is the largest circle. Okay, and we are given this has a rotational symmetry of 6, meaning if we find one of the angles, then we need one of the sectors, and you can just multiply it by 6 and boom, get the answer. So let's go. We know this angle is 40 degrees, which makes it a bit easier to work with. Now, let's calculate the sector area. How do we do this? Well, first thing is we do not need the 5 centimeters. Okay, 5 centimeters I think is for like part B or something, I don't know, but let's go 4 centimeters. Okay, we use this 4 centimeters sector. Let's try the side. We subtract this 3 centimeter sector from it. Okay, since it's 3 centimeters, we add back in 2 centimeters and we remove 1 centimeter from it. How do I know? Well, because if we just have this 4 centimeters, then we are finding this area only. So this is the 4 centimeters. If we remove 3 centimeters from this, then what do we get? Oh god, what are we left with? We are left with this black area, and if we add 2 centimeters to it, we will find this. But if we remove with the 1 centimeter from this, then we are left with this black areas also. So this is how this calculation works. Okay, and now I will solve it for you guys. Let's go step by step. Okay, unsimplified first, then we can simplify it later in calculation. Okay, manually. This is paper 1, meaning we cannot use a calculator. Okay, remember. No, I read the wrong value. Yeah, this is paper 1. Okay. So we cannot use a calculator. Okay, so let's go. 40 over 360 pi 4 squared minus 40 over 360 pi 3 squared plus 40 over 360 pi 2 squared minus 40 over 360 pi 1 squared. Okay, now this is our areas. Now we need to give in terms of pi, so we can forgive pi here. Now, if we see the common thing between all these and all 4 terms is 40 over 360 pi. So we can let's have it be common. 4 squared minus 3 squared plus 2 squared plus 1 squared minus 1 squared. Okay, let's simplify this inside. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 4 minus 1 is 3, 3 plus negative 9 is negative 6, 16 minus 6 is 10. Nice. 40 over 36 is 4 over 36. 436 is, can you simplify to 1 over 9? If we multiply by 10, this is 10 over 9 pi, and this is our answer. Okay, if you don't understand, let's rewind the video and just follow these steps carefully. Okay, that's how we get this, but we are not done. We have just found only one area of this. Okay, I almost forgot also. So we just find times 6 this. So you find this 1, 2, 3, 4, 5, 6. Nice. And if you multiply by 6, we get 20 over 3 pi. A very good answer. Okay, and this all work for 2 marks. Okay, I know, very bad, but who cares. Now a vectors question, a geometry question, and another vectors question left. Let's do the vector questions together. First the geometry questions. Okay, the question, this angle. Okay, fun fact, this thingy, this question. Okay, I had this in my paper. Okay, I gave this paper. Okay, this winter 25 1 2, and I did this connect for the first time, but then when I solved it again, but I keep getting it wrong when I do this again. But I know the correct answer now, finally. Now this is paper 1, so I cannot use my calculator. I know, scary, but let's go. We know some properties, that parallelogram will have this and this be same, but we do not need to use this. We need to use some other property. I don't know. 40, this is a isosceles, so 180 minus 40 is equal to 1. 40 over 2 is equal to 70. We know this will be 70. Nice. Similarly, this will be also 70. We can complete this angle, it being 180 minus 60 is equal to 120 minus 70 is equal to 8627. If we, this is 50, yeah, 50. So this is 50. Nice. Now 50 and x. We know that this angle should also sum up to 70. Okay, and if we see carefully, these two are parallel, and if we have read my notes, we can see a z, so we can say this is 50 also, because why? If we extend this is 50 vertically opposite, and then we can copy this down here because of corresponding, so we can say this is vertically opposite. Next, we need to complete this angle. We know x plus 50 is equal to 70, so x is equal to 20 if we minus 50 on both sides, and that is the answer. Okay, I hope I got this right. I haven't checked my script in like a long time. Let's do this question before doing the other final last question of, okay, A, B, C, D, E, F, G is this behemoth, and we need to find FB, FE, and X. Now the X bit is the where people get confused about. No, one is this, other is this. Okay, I'll do the whole question, okay, because I don't remember which bit people get stuck on. Okay, let's find FB. So FB is, you know, you can just go to OB is equals to P plus Q plus P. So this is 2P plus Q, and OF is equals to Q. Now we need to do BO plus OF because head to tail thingy, that as I mentioned, and BO is just negative 2P plus minus Q plus Q. This is negative vectors. Okay, let's read my notes. This, and so the answer is not that. What? OB? No. We are finding the opposite thing. Okay, we need to find FO plus OB. Sorry. Negative vectors, so it's negative Q plus 2P plus Q. QQ cancelled out, so we get 2P. Okay, you guys can also see it is just 2P. What? A little proof is all it takes. The possibilities. FE. Now how do we find FE? Now OE. No, if we go by P and by Q, this is this distance. So we can just basically do P plus Q. That is FE. P plus Q. Okay, I know this very simple. I know. X is a point on FB such that fx to xb is equals to 3 to 1. Find express OX as simply as possible in terms of P and Q. We know fx to xb is equals to 3 to 1. Now what is fx or xb in relation to fb? We know 3, 1 add up to 4. and we can deduce fx is equals to 3 parts 4 and bx is 1 part 4. So we know that fx is equals to 3 over 4b and xb is equals to 1 part 4 fb, fb vector. Okay, so we know this, and either we can use fx or either use b to find ox. Let's just use b. Let's just use fx to do this. We know fx is equals to 3 over 4 fb, and let's just combine plus, so it will be of plus fx. This will give us ox. Okay, sorry for the background noises if it's too loud, please. Okay, so of is q, fx will be 3 over 4 2p, which is 3 over 2p, and that is our answer, 3 over 2p. I know, very simple again, but very easy. Y is a point on BD, and this is a quadrilateral, is a trapezium. We need to find OY. Now, we know Y is a point on BD, and this thingy is a trapezium. Okay, now how is a trapezium? Okay, it is just two perpendicular lines with two non-perpendicular lines which are facing somewhere else to each other. Okay, and we need to find xy somehow. Xy. Now, a fun thing is that when I solved this type of question, I knew that OX and FY needed to be like parallel, parallel vectors to solve this case. So that's what I did. I took OX and FY to be perpendicular, to be parallel, oh my god, and did the question. Okay, so that's what we are going to do as well. So we know OX is q plus 3 over 2p, and we know Fy will be some multiplier of OX. So we can deduce Fy is equals to KOX. Next, now the question wants us to find XY. XY is XO plus OF plus FY. Okay, XO is negative OX, OF is equals to Q, and FY is MOX. So this is our equation, okay, that we need to solve. Yeah, and simply as possible in terms of P and or Q. Now, how do we find Fy? One more thing about Fy is that it lies on BD. We know that BD, if you multiply it by some constant K, is going to give us BY. BY. And using this, we know FO plus OB plus BY leads us to FY as well. So using this, we can make a simultaneous equations. Okay, so keeping this here, okay, I will just bring OF up with me, OX up with me, and let's start solving it. Okay, now to recap, we know BD, if we scale it we get BY, and OX, if we scale it we get FY, because they're parallel. Okay, so our goal is to do xy is equals to fx, no, xf plus fy. And what was fy? Fy was mox, and xy is also equal to xb plus kbd. Now I will be general here and I will just use mk. Okay, since we are using xy already as points, we will use mk as our lone variables. Okay, for to solve this you can use xy, don't worry, that's the same thing. Let's go. Xf was, as he said, 3 over 4 fb. What was fb? 2p. What was, so it is 3 over 2p. xf, yeah, this would be negative 3 over 2p. Now what is xb? This is a quarter to p, so this is a half p. So ox, now ox is that we found q plus 3 over 2p. bd is, now let's find bd first. This is q, so this is obviously 2q. Okay, I just want to solve this question quickly. Okay, now we can set up linear equations in in p and in q, in m and in k, by equating p and q terms. So if we first equate p terms, you get negative 3 over 2 plus 3 over 2 m is equals to a half p, a half. Done. Next, this is, remember, this is from p. From q we get mq is equals to 2kq. Let's just divide by q. Now this won't help us in any way, because you want to solve for one variable, you cannot solve two variables at once. Okay, so let's just skip this. Let's use this instead. This as one variable, we can solve for m safely. Now if we do 3 over 2 on that side, you get 3 over 2 m is equals to 2 multiplied by 2 on both sides. This is 3m is equals to 4, m is equals to 4 over 3. Nice, boom, we found one of them. So that means you can move forwards. Finally, you do not need a k equation u. And solving for k, we then put this into this equation. Okay, now we get 4 over 3. So we get negative 3 over 2p plus 4 over 3q. Let's multiply this carefully. 4 times these 3 cancel out, and 4 over 2 is 2, so this is 2p plus 2p, like so. And yeah, this makes sense. Okay, 4 over 3q plus 2 minus 3 over 2, which is 3 over 2. No. This is a half, yeah. Plus 1 over 2p. And that is our final answer. Okay. Any issues, just rewind the video. Any mistakes, then comment down below, please. Okay. Let's move on to this question again. This is the same premise, okay, as before. Similar premise, okay. Let's say that. Now let's skip directly to the last question. Find the position vector of x. OP is extended to point x. Oh god. So OP is extended to x and MN. X is a line. Nice. Boom. We then have this. Now we need to find OX. To do this, we know this will be sum OP is equals to, let's go to, what do we have? We are working with NM. We want to shoot this from M. So how about we do OM plus YMN. This is our equation. Okay. OM is just going towards here directly. Now OM is just 2b plus half a, 2b plus half a. YMN, let's just, OP is xp xa is equals to this, and YMN. Now we know NM is Pn to NQ is equals to 1 to 3, so this is Pn is 1, this is 2 minus a quarter, so this is 3 4, no, 2 minus a quarter. What? Wait. Oh, I'm an idiot. Times a half times 2. Yeah. Sorry. This is 3 over 2. Yeah, 3 over 2 b. Sorry, I haven't solved this question in a while. 3 over 2 b plus a half a. A half a. You know, half a. Don't worry. Now, this is the same work that we did in the upper question, which was we equate either the A position vector or the B position vector. If we equate the A position vector, we get x is equals to a half, x is equals to a half plus a half y. Next is the B terms. Now here there's no B term, so we just take it as 0. 2 plus 3 over 2y. Here you cannot solve two variables, so this is this. Here let's just do this carefully. Y is 4 over 3. If we plug this, negative 4 over 3. Yeah, I did it in my head, don't worry, you can just fact check it. And we can plug this back in because we found this. We do not need to find A. No, find x. Okay, so we plug this inside here, like the 4 over 3. So this is 2b plus a half a minus 4 over 3 over 2b plus 1 over 2a. Nice. So this is 2b plus 1 over 2a minus, let's do this carefully, 3 cancel out, 4 over 2, so this is 2b plus, carefully, 2 over 3a minus 2 over 3a. Yes, so let's just combine this cuts, and we do a half minus 2 over 3 negative 1 over 6. I think we found xp. We found xp. Yeah. Oh my god. Okay, I did a mistake here. Okay. Please, sorry. Forgive me. This is negative 3 over 2b negative a half a. I needed to reverse this vector because we are finding from mn, not nm. This is from mn. So we needed to have it a negative vector. So in this calculation, just have it be plus. So this is 2b plus this won't cancel out, by the way. Yeah, this won't cancel out. So that means this is also somewhat wrong because this is positive a, you know, a half. So this is like this. I know it's wrong on so many levels. So with that mistake, we just calculate y and x again. Okay, so doing this properly again, if we equate the b terms, okay, the b terms worked out is equals to 2b plus y times negative 3 over 2b. So this is negative 2 is equals to negative y, negative 3 over 2y. We multiply 3 over 2 on both sides, 2 times 2 over 3, this is 4 over 3 is equal to y, and done. So we do 4 over 3 y, so this is 2b plus a half a plus 4 over 3 negative 3 over 2b plus a half a. Nice. 2b plus a half a minus 2b plus 2 over 3a. Now this is the perfect equation. This cancel out. A half plus 2/3 gives us 7 over 6, which is the correct answer. 7 over 6a is the correct answer. So I hope you guys did not fall into that mistake. And I will just re-explain it before ending the video. Okay, so what did you do? We first knew that we needed to extend OP to by some multiplier. Okay, so we named it OP is equals to OX. Next, we knew that if we extend MN, then we need X also. So we do know that MN, okay, YMN is equals to MX, and we need to combine this to the origin. So OM plus MX is equals to OX, but we see this is also OX. So why don't we connect it like so? And it is like so, and we formulate this is equals plus mx. Mx is equals to ymn. What is mn? It is negative nm. So we have this. Now op is equals to a, om is equals to 3 over 2b plus a half a, 3 over 2 plus a half a plus y, and negative nm. Now nm was 3 over 2b plus minus a half a, but since it's negative, we just flip the signs. Y, and then we formulate in b. Formulating in b, we get 3 over 2 minus 3. Oh my god. This is 2b. Sorry. 2b minus 3 over 2b. That is the answer. No, that is the equation that we formulate. And if we solve for y, we get y is equal to 4 over 3. Next, we then plug it back in. We remove this. This is over x, and we solve for equation giving us 7 over 6a, and that's the answer. Bye.